Hello everyone. Today I am going to discuss about 5G and our cyclic prefix design and why it's required, how it is useful in 5G and where it is used. Means in which area. Okay. The first name itself indicates cyclic prefix. It refers to the prefixing of a symbol. Symbol is nothing but a waved in symbol. If you know the 5G frame structure, you will understand what is symbol. Okay. A main thing, the CP comes into picture because of the multipath propagation and signal distortion or signal loss. Because when we send the signal from base station to UV or UV to base station, it will pass through multiple paths. For example, sometimes it will hit the building, it will reflect, it will pass through some trees, it will scatter, or it will hit the vehicle. Some distraction, some diffraction will happen to the signal, so it will reduce the strength as well as it will reach the receiver at the different time. So due to these things, some delay will happen in the signal. So that receiver is not able to decode the data properly because of this multipath fading or propagation. So when we send the CP with our actual data, so that receiver is configured to receive the actual data only and discard the cyclic prefix. Cyclic prefix is nothing but a discontinuous transmission or unused data or same data only. So it can be anything. Okay. Okay. First we will come to what is multipath propagation. So here you can see is the base station is transmitting signal to the mobile. It is transmitting signal to the mobile through the multipath. So here you can see one signal is hitting the building and reflecting to the mobile, and another signal is passing through the tree which is scattering, shadowing, or another one is passing through building, so it is experiencing the diffraction. That signal is reaching to the mobile by passing through multiple paths. So all signals are reaching the mobile at a different time. Okay, that's what we call multipath. So here we can observe the signal occurrence at the mobile with a time. Okay, directed signal is nothing but what we are transmitting from the base station. This one is the reflected and delayed signal due to hitting into the some building or tree or vehicle, any obstacle. Okay, when it hits the any obstacle, it will reflect. So due to that reflection, there will be delay in propagation. Okay, so we are expecting the signal at this time, but it is occurring at a slightly delayed time. Slightly it is taking more time. Okay, that's the reflection one. This one is a reflection 2. It is occurring at a different time. So there is a time in between directed signal and the reflection signal, that's called a guard interval. Okay, this is our sampling window and this is our guard interval. This is what we are transmitting from base station, this is what we are receiving at the receiver. So we are transmitting this signal, we have received this signal, then how that receiver will decode the data properly. So due to these problems, to overcome these problems, cyclic prefix is come into picture. Okay. Cyclic prefix is mainly designed to overcome the ISI, inter-symbol interference, as well as inter-channel interference. Okay. So what is inter-symbol interference? There are series of symbols transmitting when we transmit the signal. So if you know the 5G frame structure, there are lot of symbols. In one frame we have 14 symbols. Okay. In one subframe we have a 14 symbol. In total one full frame we have a 140 symbols in a time domain. Okay. When it passes through the multipath, so when it hits the obstacle or building or something obstacles, it will reflect. Due to that, some delay will occur. So what happened at the receiver side, it will overlap on the another symbol. Here we are transmitting OFDM symbol. Due to the some delay, it is overlapping to the next symbol, symbol 2. That symbol 2 is overlapping on the symbol 3. So here we can see the delay spread, how much spread occurred due to the reflection. This is called inter OFDM symbol interference. So how to overcome this? This can be overcome by inserting the guard interval between the OFDM symbol. So if we insert this much of time in between two symbols, it will not overlap. Okay, that is the concept. So this is called inter-channel interference. The same thing will happen when we send the signal. It will reflect and it will occur at the different time at the receiver side. So again it will overlap to the channel. So how this CP reducing the ISI? As I told, so guard period can be inserted between OFDM symbol in the form of CP. So that CP provides some time window for the delay spread components belonging to the previous symbol, which is arrived before the start of the next symbol. Okay. So as I told, that guard period can be anything, discontinuous transmission, or it could be a transmission of anything else. Okay. So the length of the CP or guard period is generally greater than the maximum delay over the radio channel. Okay, it should be more than that delay over the radio channel. Then only we can reduce the inter-channel interference or inter-symbol interference. CP can be inserted in the guard interval to reduce the ICI. ICI is nothing but an inter-channel interference. So what they will do, they will copy the last payload at the end of the payload, transmitting as the cyclic prefix. At the receiver side, some circular convolution will happen to get or decode the data. So suppose if it not happen, that convolution is not completed, then the receiver would experience the inter-channel interference. So the major things, how to calculate the how to determine the CP length. So the CP length is directly proportional to the multiple path delay. We are transmitting signal from base station to UV, which is the maximum delay, maximum longest path. How much time it will take to reach signal from base station to UV, that is the multipath delay, maximum delay, that is proportional to the CP length. If the larger the multipath, delay requires a larger or longer CP. Then the length of the OFDM symbol also helpful to determine the CP length. Okay. If the length of the OFDM symbol is larger, we need a larger CP or longer CP. So the properties of CP in 5GNR. So mainly there are two types of CP. One is NCP and another one is a ECP. NCP is nothing but a normal cyclic prefix, and ECP is nothing but a extended cyclic prefix. So the NCP is specified for all subcarrier spacings like 15 kilohertz, 30 kilohertz, 60, 120 to 40, like that. Then ECP is currently only specified for 60 kilohertz subcarrier spacing. So if the normal CP is used, the CP of the first symbol present every 0.5 millisecond, which is longer than the other symbols. Okay, the first CP will be a larger than other CPs, as the subcarrier spacing and CP duration is inversely proportional. Means as increasing the subcarrier spacing, the duration of the CP will be decrease. So here is the that distance. Based on the CP length, we can determine how much distance it can carry the data without intersymbol interference. Here I have taken one example, 15 kilohertz, having the CP for long symbol 5.2 microsecond, and the velocity of the signal is usually that equal to the velocity of light, which is 3 into 10 raised to 8 milliseconds per second. So the distance is calculated, that velocity into time. Okay, it will give you 1560 meter. So like that, for different subcarrier spacing, different distance will come. Okay, here you can see in the below diagram. Thank you.